All right, so this is your Chapter 2 review. Functions is the main theme. So we have all types of functions, and first and foremost, we talk about when given a function, what is its domain and range? Let me turn on another light real quick. All right. This is not focusing at first. There we go. Okay. It says state the domain and range of the following functions. So there's two ways you can do it. You can think of it logically, or draw like a sketch, a baby graph, and look at the domain and range. So if I have y equals x, that's y equals 1x plus 0, technically. You begin with b and you move with m. So logically, can I put any number I want into a linear equation? Are there going to be any errors? No. So your domain would be what? All real numbers. I can put anything in I want. If we went over here to our x values and we try to put a barrier here and a barrier here, there aren't any barriers it's going to break through. It's not restricted. So our domain is all real numbers. Your textbook might use the notation x is an element of all the real numbers. Either one's fine. Okay, I'm not picky about notation. However, in your higher level math courses is where they're going to start being more particular about how you notate your math. Right now, I'm desiring you to get the process. Okay, range. If anything can come in, more than likely anything can come out. We see here that it extends to all the positives, it extends to all the negatives on the y value. There's no barriers. If I put barriers, it's going to break through. So there's no barriers here as well. So you could say all real numbers, or you could say y is an element of all the real numbers. You don't have to put both of these things. I'm just showing you one or the other. Okay. Can I square any number I want? Absolutely. All real numbers. What comes out? Well, I'm squaring, so wouldn't it be only positives? Let's look at a graph. I have I have x squared, but that minus 2 is going to knock your graph down here. And this is your graph. So once again, we could try the barrier method and say, here, is there a barrier here and here? No, it's going to keep going. So there's no restrictions. So it's all real numbers. But if I go here, I start at -2, not just positives, because I was moved down, and I can keep going all the way to infinity. So y is greater than or equal to -2. Here, we have the absolute value of x, but it's vertically stretched by a factor of 3. So it's going to look something like this, probably a little bit more severe. Domain, what values can I take the absolute value of? Anything. Or if I put barriers here, they'll break through them. So it's not restricted. There's no barriers. It's all real numbers. You can notate like this or like this, doesn't matter. The range, when I take the absolute values of numbers, I either get positive or 0 if I put in 0. Well, yeah, I can put a barrier at 0 and I can keep going. Okay. Number 4. Usually all these will be all real numbers unless you run into an issue. So here we have division. Where do we run into errors with division? What can't we divide by? We can't divide by 0. Try it in your calculator. 5 divided by 0, Okay, it doesn't work. It's undefined. So our domain is x cannot equal 0. You can put all real numbers, comma, x cannot equal 0. That's fine too. If you just put this, it's understood it's every other number but 0. So if you graph it, it'll show you. There won't be a barrier here or here. It'll bust through those. But you notice here, there's nothing there. It can't be 0. And if it can't be divided by 0, look this way. It will never equal 0 either because it has to have 0 on top, which it never will. So the range is y cannot equal 0. Number 5, it's a linear equation. So just like number 1, it's going to be all real numbers and all real numbers. If you begin with B and you move with M, you'll see it's a linear equation, no barriers, no barriers. The domain is all real numbers and the range is all real numbers. I can put anything in and anything will come out. Here it's saying y is always 3. So no matter what, your range, your output is always 3. So what can I put in? Well, anything. Y is always 3. If I put in negatives, y is always 3. If I put in positives, y is always 3. 1, 2, 3. We always have an output. Doesn't matter what x is. If it was x equals 3, then the domain is x equals 3 always, and your range would be all real numbers. Okay? So it says, given the function, find f of negative 2 and find f of x minus 1. So wherever I see a negative 2, or I'm sorry, an x, I'm just going to replace it with negative 2. So we square the number, then multiply by 2. PEMDAS, you have to go in order. Okay? Here, you put in x minus 1 wherever you see x. You have to FOIL first. That's it. Students start to try to solve. They're not asking you to solve. They said, given the function, find. This is evaluating. This is substituting and simplifying. That's it. You're not solving. The word solve is nowhere. Okay? Here, it says solve the proportion. Okay? We were talking about proportions because we were talking about direct variation. So a times the quantity a minus 1 is equal to 6 times 2. A squared minus a equals 12. Since it said solve, you have to bring everything to one side and factor. You know it's going to be a and a. How do you get a negative 12? Well, one thing has to be positive and one thing has to be negative. The larger number will be negative. We need a negative 1. So what two numbers that give you 12 are going to be close to 1? If I pick 6 and 2, I'll never get a 1. If I pick a 12 and 1, I'll never get a 1. If I pick 4 and 3, that will give me negative 1. So let's check. A squared, check. Negative 4a, positive 3a, negative 1, 3 times 4, 12. Yep. So the zero product property. The zero product property says that if two things being multiplied together equals 0, you can set each piece or factor equal to 0 and solve. So if I substitute back in negative 3 and if I substitute back in 4, this will be true. So those are your answers. Okay. We're going to do this in 2 videos. Okay. Now we're going to talk about direct joint inverse variation. So it says, write an equation of variation to represent the situation and solve for the missing information. A varies directly as B. So A equals KB. It says B equals 1, A equals 5. Well, therefore, what's K? K is 5. They said to write an equation of variation. Well, if K is 5, then the equation is A equals 5B. Okay, now they want you to use this equation to find B when A is 2. So divide both sides by 5. B equals 2/5. So I should have two things circled, the equation of variation and the missing information. Okay, all these should have two answers. This one says Z varies jointly as X and Y. It says X equals 3, Y equals 2, and Z equals 12. So 12 equals 6K, therefore K equals 2. If K equals 2, then the original equation is no matter what Z, X, and Y are, K will always be 2. So using that, I want to find Z when X is 4 and Y is 5. 20 times 2, Z is going to be 40. So the equation and the piece of missing information. The time needed to paint a fence varies directly with the length of the fence. Yeah, bigger fence, more time. And indirectly with the number of painters. Yeah, more painters, less time. If it takes 6 hours to paint 400 feet of fence with 3 painters, how long will it take to paint 500 feet of fence, way more feet of fence, with 6 painters? Okay, more painters, but also more fence. So this, if I multiply 3 to the other side, and divide by 400, K is going to be equal to 18 over 400, which is 0.045. So my equation is T equals 0.045 length and P. So that's my answer. And then I got to take that 0.045 with the new information, and I'm going to get 3.75 hours, which is 3 hours and 45 minutes. I don't know why I skipped this one on accident, so let's go back. It says the time needed to travel a certain distance varies inversely. The time needed to travel a certain distance varies inversely with the rate of speed. If it takes 11 hours to travel a certain distance at 45 miles per hour, how long will it take to travel the same distance at 60 miles per hour? Well, it's going to be more speed, so probably less time. So if I move 45 to the other side, K equals 495, and 495 divided by 60 is 8.25 hours, because 11 was hours. Well, I wrote the piece of missing information, but did I write the equation? No. Therefore, my equation is time is going to always be different, and so is speed, but this relationship between them is not. So I should always have two answers. All right, last two. An egg is dropped from the roof of a building. The distance it falls varies directly with the square of the time it falls. If it takes a half a second for the egg to fall 8 feet, multiply by 4. So this is my equation. Then how long will it take an egg to fall 400 feet? Okay. The temperature T in degrees Kelvin of an enclosed gas varies jointly with the product of the volume, temperature and volume, and the pressure. Okay, the temperature of a gas is 294 kelvins when the volume is 800 cubic centimeters and the pressure is 0.75 kilograms per square centimeter. Okay, it's a lot of words. It's wordy. But if you can just designate T here, V here, P here, temp, volume, pressure. Okay, what is K then? .49. Therefore, your equation is 0.49 volume. Okay? It says, what is the temperature when the volume is 7,000 cubic centimeters and the pressure is 0.87 kilograms per square centimeter? So take 0.49 times 7,000 times 0.87. Temperature. That's pretty high for kelvins. Is that accurate? Yeah, if the pressure is 7,000 and the pressure used to be, oh, that's why, because here it's 8,000. I was going to say that seemed off. Okay, so it's 8,000 here. My apologies. And then take 294 divided by 6,000. 0.0. There we go. We should have just known that instinctually with the 0. Sorry. Okay. So 0.049 times 7,000 times 0.87. Bring that over because of the 0. So 298 degrees Kelvin. Okay. All right. This is the first half of the video. You should be, if you're midway with the chapter, you should be okay with that. All right. The second video will be shortly after.